gold, silver, diamond, oil. These are raw materials that are very scarce in our world today. And we people, human beings, intend to value it because of its rarity. However, is these raw materials very important to us? Well, we human beings are physical and emotional animals. Time, manpower, machine, food, and cash. These are the resources that are related and connected to us. Why? Because we use it every day. And we encounter it every day. We consume it. We use it. We utilize it. But the more we use it, the more it became scarce. Why though? Because if something can consume, then it will use up and become less, right? And our world population is increasing. And due to increasing of population, we consume and use more this kind of materials. Time, machine, money, and food. These are the common raw materials that we use. But the question is, how can we resolve it? Since population control, we could not just take it over in just one place, right? So, in order for us to solve this, we think outside of the box. We just use our raw materials proficiently and distributionally. How can we do that? By the use of linear programming. And today, that is what I'm going to discuss. The linear programming and how it solves our problem. What is linear programming? Linear programming is a mathematical modeling technique in which a linear function is maximized or minimized when subject to various constraints. What do you mean by that? Linear programming involves mathematical modeling technique. So, which means we are using mathematics to solve a problem. And it said here that it has a linear function which is used to maximize or minimize and subjected to constraints. So as you hear linear programming, as the word programming, we are not intended to do some code programming right here or coding language right here. We are just doing a solving problem involving a optimization. So the word programming here, the key point of programming here is all about planning, and the linear is all about the relationship between two variables. Yes, we're going to use variables in our discussion. As you can see here, you can see three icons. The first is the book, the second one is the salesman, and the third one was the gadgets. Now, the first icon said it was for the students to finish his project in just 15 days. And here right here is a salesman who wants to get a sales target in a month. And a person right here want to buy a gadget within a budget of $500. Now, what is the connection between this icon to linear programming? Well, it's just a example of where does linear programming could be applied. So let's just focus on the first icon, which is one. On the first icon, the students want to finish its project in 15 days. And the second icon was a salesperson want to get a sales target in a month. And a guy right here at the third icon want to buy a gadget within a budget of $500. So as you can see here, they have a commonality, or they have in common. What have them in common are their objectives. They have own objectives. Well, the student want to get a maximum score because he want to finish it in 15 days. While the salesperson wants a maximum sales in a month. And the guy in the third icon want to minimize the cost because he had only $500 budget. Now, you may think, oh my god, it's easy, right? Because you want to get the maximum score, maximum sales in a month, and minimize the cost. However, there is a limiting factor. And what is it? Each of them had limiting factor. The students have a limiting factor of time because he had only 15 days to do the homework or the project in 15 days. The salesperson had also a limiting factor of time. Well, the gadget guy have also a limiting factor of pre-decided budget because he had only $500 to buy a gadget. Now, what is the meaning behind this? And what is the connection between the linear programming and this? So, the aim of linear programming is to find the optimum solution subject to constraints of the problem. So they have problem, right? They have problem because they have limiting factor of time also, and pre-decided budget. So I'm going to discuss linear programming. However, solving linear programming or optimization problem had two ways of method to solve it. First is the graphical method, next is the simplex method. But we're going to dig deeper on graphical method because it is easy and it was tasked to me. Now, before we get into the method of graphical solving, we just want to introduce you the X and Y coordinate system or the graphical method. You are familiar with the graphical method, which is the graphical method. No, you are familiar with the XY coordinate system, the rectangular coordinate system, which has the X-axis and the Y-axis. And we're gonna use it in our discussion further. So before we do linear programming, so we must have common terminologies to be familiar with. First is the decision variables. X and Y are the decision variables, and objective function. Non-negative constraint. This condition X and Y is greater than or equal to are called non-negative constraints. Next is constraints. The linear inequalities or equation of variables of a linear programming problem are called constraints. Optimization problem. This is a problem which seeks to minimize or maximize a linear function subject to a certain constraint as found by a set of linear inequalities. LPP are such special types of optimization problems. So optimization problems is the problem we're going to solve using linear programming later. Next, the feasible region. The region which is common to all constraints including the non-negative constraints is referred to as feasible region. Next is feasible region. It is the region of other than feasible region. Next is special objective function. The real valued function whose value is to be either minimized or maximized subject to the constraint. The objective function is needed to solve the optimization problems. An objective function is a linear function represented as by z is equals to ax plus by, where are constraints and are variables. So guidelines for solving linear programming using graphical method. So we're having a guidelines to solve linear programming so that we could not lose in the process. So step 1, set up the linear programming model. So we just need to represent the unknown in the problem, and we may tabulate the data about the unknowns if necessary to make it more arranged or organized. Then we need to formulate the objective function and constraints. That is the step 1. Step 2 is shade the feasible region. Here you are going to graph the constraints. The feasible region is the shaded region consisting of the set of points that holds the explicit and implicit constraints true. Step 3, determine the coordinates of the vertices of the feasible region. You solve for coordinates at the point of intersection of lines. The vertices of the feasible are the corner points in the feasible region, and these are the points where the boundary lines in the graph of the set of the constraints enclosing the feasible region intersect. These corner points are to be tested and substituted to the decision variables in our objective function. Step 4. Substitute the coordinates of the vertices of the feasible region to the objective function. Step 5, last step, is choose the vertex that gives you the greatest value for the maximum problem and pick the vertex that will result in the least value for minimization. The maximum or minimum value of the objective function is called the optimum solution of the system. So now we know the guidelines for solving linear programming using graphical method. We could now get into solving a word problem. Now I have a word problem right here. So we can solve it by using linear programming. So a company manufactures two products, A and B. Each product requires the use of two machines, M1 and M2. The processing time for each unit of product A on machine M1 is 2 hours, and on machine M2 is 1 hour. For product B, the processing time is 1 hour on M1 and 3 hours on M2. The company has a total of 40 hours available on machine M1 and 30 hours available on machine M2 each day. Profit for each unit of product A is $5, and for product B is $8. determine the number of units of A and B to produce for maximum profit. So, to solve it, we need to analyze the problem. And step 1, we need to set up our linear programming model. So, after we analyze our problem, we must know what is the goal of this problem. So, you can see here, the goal of the problem is he wants to determine the number of units of AB to produce the maximum profit. So, which means he wants to get a maximum profit. And that would be his goal, the goal of the problem. Now, what would be the limiting factor of this? So, the limiting factor of this problem, as you can see here, we have M1 and M2, which is representing as machine, and time, which is the 3 hours and the 2 hours of the machine that will be used up in the process, machine and the time. Now, after we know limiting factor and our goal, we could now determine the unknown values or the representative of unknown values. Now, we have two products, the product A and product B. So the product A, let's just represent it as X, and product B, let's represent it as Y. Now, as you can see here, the next step we're going to do is to get the objective function. So how can we do that? The objective function is the main function that determines the maximum profit on our problem. And we want, if we say profit, then we say it is all about the money. And you see on the problem, there is $5 and $8. And product A is $5 and product B is $8. So that would be representing as the value of our objective function. We say that 5x is equals to product A and 8y is equal to y, because we could multiply it both x and we could multiply 8y to make a certain result. Since we get these 5x and 8y, we could now use, or we could now get our objective function, which is z is equals to 5x plus 8y, which is to get the maximum profit. And after we get our objective function, we may now use or find or determine the constraints. So we are now know that our limiting factor is the machine and the time. We could use the table to make our data organized and structural. Now, X and Y, this is the product A and product B, and M1 and M2 is the machine that used to create product A and product B. And machine 1 and machine 2 had their limiting factor, which is time, because they will be used up at a certain amount of time. Now, at X, on machine 1 and product A, it can only be used for only 2 hours. On machine Y and machine 1, the product B to be used for only 1 hour, with the constraints of 40 hours for machine 1, because it only used for 40 hours a day. So we use the less than and equal to symbol, because we know the maximum usage of the machine. Next, on machine 2, on product A, it could only use 1 hour to make product A and 3 hours to make a product B, and have a limiting time of 30 hours. Since we get the certain values and variables, we could now get our equation. Our first equation is 2x plus y less than or equals to 40, which is corresponding to this equation right here. Next, we get the equation 2, which is x plus 3y less than or equal to 30, which is right here. And after that, we need to have the rule of implicit constraints, because we don't want our value of x and y to be negative, because our limiting factor is all about time, because time cannot be moved backwards. So we just want a value of greater than 0, not be less than by 0. Now, after we get our equation, our step 2 is to get the feasible region, which is to graph it. So we need to move our equation right here, 2x plus y plus 40. So the next thing we need to do is to graph it, to graph the lines. So how can we graph it? So the first thing we need to do is to graph the first line by using the intercept method. So the first equation became 2x plus y is equals to 40. By solving or by graphing using intercept method, we substitute 0 to x and y to get the x-intercept and the y-intercept. So I'm going to get first the x-intercept of the equation. So I'm going to substitute 0 to y, which is right here. 2x plus 0 is equals to 40. And then I'm going to substitute, I'm going to simplify it. It become 2x is equals to 40. Then I'm going to divide it by 2 or multiply it by 1/2, and I get x is equals to 20 with an ordered pair of 20 and 0. Now after I get the x-intercept, I'm going to get the y-intercept. I'm going to substitute 0 to x, and I would left it as y is equals to 40, which is an ordered pair of 0 and 40. Then, by determining the x and y intercept, I could now graph immediately the equation. Now locate the ordered pair of 20, 0, which is right here, and locate the graph of 0 and 40, which is right here. Now connect the points to make a line. And now we graph the first equation. The next thing we need to do is to graph the second equation. Now put the equation right here and get x plus 3y equals to 0 is equals to 30. Now, and the next thing we need to do is to find the x and y intercept. So I'm going to get the x intercept first. So I'm going to substitute 0 at y, and then I have x is equals to 30. Then I have an ordered pair of 30 and 0. Then I'm going to get the y-intercept. I got x plus 3y is equals to 30. Substitute 0 to x and divide by both sides by 3, or 1/3 multiplied by 1/3, and I get y is equals to 10 with an ordered pair of 0 and 10. Now I get the x and y-intercept. I could graph it now. Put the 30 right here, put it right there, and I could now connect it with using the line right there. Then we must know where should be the shaded part, and since we graph it, and as you can see here, our graph right here would be have a shaded part, shaded region. I'm going to erase it. Oh, what's happening? Shaded region. So since our equation 1 is less than or equal to y, which means our shaded region on the line is right here. This is our shaded region on our first line. And our second region is our second shaded region is for the equation number 2 is right here, because it is less than or equal to. See, if you say it is equal to, it is less than or equal to, or less than or equal to, it should be the shaded region, which should be the left part of the line, and that's over here. Since we know where should be the shaded region, we must determine the intersection of the shaded region between the two lines, and that will be our visible region, and that will be here, right here. So I'm going to erase it. After we get our visible region, we determine the region. The next step is to find to get the vertices. Now we have vertices of 0 and 0, 20 and 0, and 0 and 10. However, we do not know specifically what should be the vertices or the coordinate points right here. To get the coordinate points right here, we will use the system of linear inequalities. And how can we do that? To solve for linear inequalities using systematically, we make equation 1 and equation 2 to its function form, which is y is equals to 40 minus 2x, and y is equals to 30 minus x all over 3 to the equation 2. The next step is to combine them, or to substitute this expression to the y, and we have 40 minus 2x is equals to 30 minus x over 3. And then I'm going to multiply it both sides by 3 to cancel out the fraction 3 at the right side. Then I could get 120 minus 6x is equals to 30 minus x. Simplify it, transmuting same variables and constants to their corresponding partner. Now I would have 90 is equals to 5x, and divided by both sides by 5, or multiplying by 1/5, I could get x is equals to 8. Now that I get the x value, I could now find the y value by substituting it to the first equation. By substituting it, I could get y is equals to 14 minus 2 times 18, which is 36. I would get y is equals to 4. Then I now determine what is the coordinate point right here, and that is 18 and 4. Then after we get the vertices of the feasible region, the step 4 is to insert the values in the objective function. Since our objective function is z is equals to 5x plus 8y, and our vertices is right here, 0, 0, and 0, 10, and 20, and 0, 18, 14. So we're going to use a table. So the first thing is to insert this ordered pair to the function, and we get $0 because multiplied by 0 and 0, we get $0. And now we substitute this ordered pair, 0 and 10, and we get $80. And substituting it, the next ordered pair is 20 and 0, and we get $100. And substituting 18 and 4, and we get $122. The next step is to find the ordered pair which gives the maximum profit of the problem, which is the 18 and 40. And that would be our solution of our problem. Therefore, the maximum profit of the company with the maximum value, which is x is equals to 18 and y is equals to 4, which is the number of product A and product B, which could profit for about $122. And that's how you solve a linear programming problem. Now, let's move on to another example. Now, a farmer has a field of 120 acres of wheat and barley. Each acre of wheat requires 2 hours of labor, and each acre of barley requires 3 hours of labor. The labor available is limited to 240 hours. The profit per acre of wheat is $100, and the profit per acre of barley is $150. Determine the number of acres of each crop to maximize profit. Now, the first thing we need to do, as the same as we solved the other problem, is to analyze our problem. Then after we analyze, we must now go into the step 1, set up the linear programming model. Now, the first thing we need to do is to know the objectives or the goal of the problem. So it said here that he wants to maximize its profit, so that would be his goal. And the limiting factor, which would be the area which the crop would be planted, and time, because it was only limited for 240 hours. Now, the next thing we need to do, since we know the goal and limiting factor, we now represent our unknown values by variables. Now let's represent x as wheat, y as barley, and we have 100x and 150y. The next thing we need to do is to get the objective function, and we have z is equals to 100x plus 150y. The next thing is to get the constraints. We know that the constraints of this problem is the area and the time. So we have, for the area for the wheat, we have only 1 acre per acre, and 1 acre for also in barley, and we have 120 acres, limited to 120 acres to plant the wheat and the barley. Then we have time, 2x, and the time of barley to plant as 3y, and we have 240 hours as the limit, our limitation. And after that, we now could formulate our equation. Equation 1, we have x plus y less than or equal to 120. Equation 2, 2x plus 3y less than or equal to 240. And we have our implicit constraints. Next is to find the feasible region or to graph the line. We use the intercept method. We first solve for the first equation. Substitute 0 to y to get the x-intercept, which is an ordered pair of 120 and 0. Next thing is to get the y-intercept, and substitute 0 to x, then we get y equals 120 and 0 and 120. Then locate the data and graph the line. Then we now solve for the graph for the equation 2. We have 2x plus 3y equals to 40. I'm going to get the x-intercept first. Substitute 0 to y. 2x is equals to 240 and divide by both sides by 2. And we have And we have 120, which is 120 and 0 as an ordered pair. Then I'm going to get the y-intercept. I'm going to substitute 0 to x, and I have 0 plus 3y equals to 240. I have 240. Then divide by both sides by 3 or multiply it by 1/3. And we have 80 with an ordered pair of 0 and 80. Now we could graph it. And after that, we're gonna find the intersection between the two lines and get the vertices, which is right here and right here, and we have our feasible region. Now to get the intersection between the two lines, we need to have the function form of the two equation, and substitute y to other expression, which is 240 minus 2x divided by 3 equals to 120 minus x. Multiply both sides by 3 to remove the fraction of 3. Then we have 240 minus 2x is equals to 360 minus 3x. Then simplify, we have x is equals to 120. Then substitute 120 to first equation. We have 120 minus 120, which is 0, which means our ordered pair from the intersection between two lines is 120 and 0. Then we need to get the vertices of the feasible region. And after we get the vertices of the feasible region, we could now insert it to our objective function, which is z is equals to 100x plus 150y. And we have our three vertices, which is 0, 0, 0, 20, and 120, 0. Since we are going to find the maximum profit, so we're going to get the ordered pairs that give a maximum profit. Now we need to insert the first ordered pair, and we get $0. Second ordered pair, and we get $3,000. Next ordered pair, and we get $12,000. So therefore, we need to choose the ordered pair that generates maximum profit. So therefore, the maximum profit will make by the farmer will be 12,000 if he will crop with 120 wheat and 0 barley. And that is example number 2. Next example. A company produces two types of product, X and Y. Each product requires processing on two machines, A and B. The time required for the 1 unit of product X on machine A is 3 hours. On machine B is 2 hours. For product Y, the processing time is 2 hours on machine A and 4 hours on machine B. The company has a total of 30 hours available on machine A and 20 hours on machine B. If the profit per unit of X is $5 and of Y is $8, determine the number of units of each product to maximize profit. Step 1, we need to set up our linear programming model. The objective of the problem is to get the maximum profit, and the limiting constraints are the time and the machine. So that we represent our unknown values, which is X represented as the product X and Y representing as the product Y. And we need to find the objective function, which is 5x plus 8y, which is equals to z. And after we get our objective function, we now do find the constraints, which is the machine 1 and machine 2 is the limiting factor. Now we have 3x equals to 3 hours for the machine 1, and could only 2 hours for machine 1 for the product Y, and it should be limited to 30 hours. Next, on machine 2 for the product X, it could only generate product X as in 2 hours and 4 hours for the product Y. We have a limiting time of 20 hours. Now get our equation 1 and equation 2, and we have 3x plus 2y less than or equal 30 and 2x plus 4y less than or equal to 20 with our implicit constraints, which is always greater than or equals to 0. Now, the next thing we need to do is to graph the two lines. By using the intercept method, we could graph the first equation and the second equation. I'm gonna graph first this first equation, and it will transform to 3x plus 2y equals to 30. Substitute 0 to y because I want to get first the x-intercept. Now we have 3x plus 2 times 0 is equals to 30. Simplify, we have 3x equals to 30 and divided by 3 or multiplying by 1/3, and we get 10. An ordered pair of 10 and 0. Now the y-intercept, substitute 0 to x, and we have y is equals to 15. An ordered pair of 0 and 15. Now plot the points and graph it with a line. Next thing is the second line, or second equation. 2x plus 4y is equals to 20. Substitute 0 to y, and we have x is equals to 10 with an ordered pair of 10 and 0. And substitute 0 to x, and we have 2 times 0 plus 4y equals 20, which is divided by 4 or multiplied by 1/4, and we have 5 with an ordered pair of 0 and 5. Plot the points, and we have 0, 1, 5, and 10, and 0. Then, the next thing we need to do is to find the feasible region and get the vertices. To know the intersection between the two lines, and it is also the a part of the vertices of the feasible region. Would be the graph right here, and the feasible region is right here. Now, by using the system of linear inequalities, we need to transform both equations into their function form, and substitute both sides, multiply by 2 and 4, and we get this equation. Simplify, and we get x is equals to 10. Now substitute this x to 10. Substitute this x to the first equation, and we have 30 minus 30, which is 0, 0 over 2, which is 0. And we know that the vertices, or the intersection between the two lines, is 10, 0. Then after we get the vertices, we could now substitute it or insert it on our objective function, which is the 0, 0, 0, 0, 10, and 10, 0. First, we need to insert the first ordered pair, which results to $0, and 0 and 10, which results to $80, 10 and 0, which results to $50. Which we conclude that 0 and 10 ordered pair should be the solution of our problem, because it gives maximum profit of $80. Therefore, the maximum profit of the company with the maximum value of x is equals to 0 and y is equals to 10, which is x represents as the wheat and y represents as the barley. So they could profit as the maximum of $80. So our answer is 0 and 10. Next problem. So a company manufactures two models of smartphones, A and B. Each model requires the use of two machines, M1 and M2. The production time for each unit of model A on machine M1 is 4 hours and on machine 2 is 3 hours. For model B, the production time is 2 hours on M1 and 5 hours on M2. The company has a total of 40 hours available on machine 1 and 30 hours available on machine 2 each day. If the profit for each unit of model A is $10 and for model B is $15, determine the number of units of A and B to produce for maximum profit. Though, we need first set up our linear programming and know their goal. Their goal is to have maximum profit. And the limiting factor should be the time and also the machine, which is the same from the other example. Next, we need to represent our unknown, which is x is equal to product A and y is equal to product B. And we have $10 and $15. $10 for product A and $15 for product B. And then we could get our objective function, because z is equal to 10x plus 15y. Next is the constraints. We have machine 1 and machine 2. On machine 1, it could only generate number of x by 4 hours. And in machine 2, it generate number of x for 3 hours. And all corresponding with y, we have 2 hours and 5 hours for machine 1 and machine 2. With a constraint of 40 hours for machine 1 and 30 hours for machine 2. Get our equations. 4x plus 2y less than or equal to 40. 3x plus 5y less than or equal to 30. When we have our represent function, which is 0, always be greater than or equal to 0. Next is to graph. We have 4x plus 2y with our equation 1 and equation 2. First, the equation 1. Substitute 0 to y. And we have x is equals to 10 with our ordered pair of 10 and 0. Substitute 0 to x, and we have y is equals to 20, which is an ordered pair of 0 and 20. Now plot the points, and we have the line. Next is the second equation. Substitute 0 to y, and then we have 10 and 0. Substitute 0 to x, and we have y is equals to 6 with 6, 0 and 6. Plot the points. And the next thing we need to do is to determine the feasible region. Since this is less than or equal to, which means the graph will be right here. And the graph of the second line will be right here. And the feasible region is located at here. Now, we need to get the vertices. Since we don't know the intersection between the two lines, and it also included in our feasible region, we could use our system of linear inequalities. Y is equals to 40 minus 4x over 2. Y is equals to 30 minus 3x all over 5. Now substitute both sides and simplify, and we have x is equals to 10, and substitute it to the first function or equation, and we have y is equals to 0 over 2, which is 0. Then we know that our intersection point is 10 and 0. And that would be to find our vertices. And after we get our vertices, is to insert it on our objective function, which is our vertices points are 0, 0, 0, 6, 10, and 0. Now we need to substitute first the 0, 0, and we get $0. Then 0, 6, and we get $90. And 10 and 0, and we get $100. So therefore, 10 and 0 is the solution of our problem, which could generate $100 of profit. On our last example, example number 5. A dietitian is planning a meal that consists of two types of food, X and Y. Each gram of X contains 2 units of protein, 1 unit of fat, and 3 units of carbohydrates. Each gram of Y contains 1 unit of protein, 2 units of fat, and 2 units of carbohydrates. The diet must provide a minimum of 15 units of protein, 10 units of fat, and 20 units of carbohydrate. If the cost per gram of X is $2 and of Y is $3, determine the amount of X and Y to include in the meal to minimize the cost. Now, first thing we need to do is to analyze the problem, since this problem has 3 components. Step 1, we need to set up our linear programming model. Next is to determine the objectives or the goal of the problem. So it said here that the dietitian want to minimize the cost with including X and Y in the meal. So his goal is to minimize the cost. So the limiting factor here is the money, because he had only want to buy in a certain amount. Now let's determine the unknown values or represent it as variables. I represent X as the food X and Y as the food Y. And food X is $2 and food Y is $3. And we could now formulate our objective function, which is z is equals to 2x plus 3y. And then the constraints. Since we have 3 components, which is protein, fat, and carbs, then we know that we have 3 equations to be formulated. Now at product X, we have 2 units of protein, and product Y, we have 1 units of protein, which dietitian needs only at least 15 units of protein. Next is the fat. At product X have 1 unit of fat, and at product Y had 2 units of Y, and the dietitian want only at least 10 units of fat. Now the carbs, it has 3 units for the product X, 2 units for the product Y, and the dietitian only needs at least 20 carbs. Now determine our equation, and we have 3 equation. The next thing we need to do is to graph it and to find the solutions that can make or can formulate that can get the minimized cost. Now we have 2x. I will have equation 1, equation 2, and equation 3. Now we're gonna use again the intercept method to find the ordered pairs or the coordinate points of the equations to graph a line. I'm going to graph first the equation 1, intercept method. The same thing we do, substituting 0 to y, and we get 15 over 2, which is ordered pair of 15 over 2 equals 0. Then for y-intercept, substitute 0 to x, and we get 0 and 15. Now we have an ordered pair to graph the first equation. Next is the second equation. I'm gonna graph it later so that I could have more space to graph it. Now we're going to find the ordered pairs of the equation 2. Substitute 0 to y, and we get x is equals to 10, which is an ordered pair of 10 and 0. Substitute 0 to x, and we get y is equals to 2, an ordered pair of 0 and 2. Lastly, the third equation. Substitute 0 to y, and we get x is equals to 20 over 3 with an ordered pair of 20 over 3, 0. Next, substitute 0 to y, to x, and we get y is equals to 10 with an ordered pair of 0 and 10. After we get the ordered pairs, we could now graph the equations. And we have an equation right here, equation 1, equation 2, equation 3, with corresponding ordered pairs. So first we need to plot the equation 1. Put the 15 0 right here, and we have this line. Next is the equation 2, this right here, and right here, and we have this line. and equation 3 right there, right here, and you have here. The next thing we need to do is to find the feasible region. Since this linear inequality is all about greater than equal to, which means the shaded part of these lines should be at the right side, which is right here. And also the line right here should be the shaded line is right here and right here. The intersection of the shaded part of those lines should be the feasible region, which is in the center or the middle of the graph. Right there. Now the next thing we need to do is to get the vertices. However, there's a problem. We do not know the vertices right here and right here. So what should we gonna do is use the system of linear inequalities. As you can notice, the equation 1 and equation 2 of the line is intersecting. Therefore, this is the coordinate points here is the intersection between the equation 1 and equation 2. And here, this is the intersection of equation 2 and equation 3. So the ordered pair right here is the intersection of equation 1 and equation 2. Now, we need to first solve for the equation 1 and equation 2 intersection right here. So we have 10 minus x over 2 equals to 15 minus 2x multiplied by 2 both sides. And we have 10 minus x equals to 30 minus 4x. Then simplify, and we get x is equals to 20 over 3. Then substitute this value to the first equation, and we have y is equals to 15 minus 2x. Substitute the corresponding value, and we have y is equals to 5 over 3, which is our coordinate points right here in the intersection of equation 1 and equation 2. Next is to find the intersection between equation 1 and equation 2, and we have 10 minus x all over 2 is equals to 20 minus 3x all over 2. Multiply both sides by 2, and we have 20 minus 2x is equals to 40 minus 6x. Simplify, and we get x is equals to 5. Substitute this value to the first equation, and we get y is equals to 5 2, which is the coordinate points of the intersection between the equation 1 and equation 3 right here. Then we get the step 3 is we get the vertices, which is the 0 15, 0 10, 20 over 3, 5 3, and 5 over 2. And after we get our vertices, the final destination will be to insert it on our objective function. Now we could now put a table for x and y and z. First, we need to substitute the first ordered pair, which is 0 and 15, and we get the results of $45, which is so very high. We need to find the minimum cost to get the certain amount of nutrients. Now we substitute the 0 and 10, and we get $30. The 20 over 3 and 5 over 3, and we get $18.34. And the 5 and 5 over 2, and we get $17.5. So the last step is to find the minimum value right here, or the minimized cost, which is 17.5 is the only one who is minimum of the value right here. So which means we need to consume 5 product x and 5 over 2 or 2.5 of product y. So therefore, the dietitian must consume 5 product of x and 2.5 of product y to gain the target nutrients that only cost $17.5. Now, you just witnessed how to solve linear programming. Have you learned something? Then I'm glad to know that. Now, those problems are problem about optimization problem. And we get the solution for those problems by using linear programming. And that's how linear programming is so very special on solving our problem involving raw materials and resources, such as time, machine, manpower, money, and food. That's it. And thank you and have a nice day.